Czyli co, zaczynamy. Witam wszystkich bardzo serdecznie. And I think that's all that I'm going to say in Polish, because we're supposed to talk English. Welcome to our talk called Making Mistakes with Events, one event at a time. But as you can imagine, this is quite a lot of words to say, so we're a bit lazy sometimes. So you can shorten it to events and eventfully. Pun intended. To make things easy, my name is Andrzej Grzesik. I know most of you can say that. In the internet, I go by Axe, because then those who cannot say it can also say it. And I have a Twitter, email, feel free to. And just very recently started to work with LMAX, .lmax. A couple facts about me. I feel related to those icons. And that's enough about me. Let's hear about Wojtek.
And I'm here the second time on this stage today. So if you see me the third time, it means it's very late. Yeah, I build stuff, teams and products. Work at the moment at Revolut, but if you want to spend some time with me at the after party, I can also talk about one of my passions is engineering leadership and everything that can kill me as a sport. So I do quite a lot of strange stuff. With that disclaimer, all opinions are ours. So if you have these tomatoes ready, that's there for us, not for our companies.
Also, if you have any questions about the talk, you can extend your limb towards just upwards, and we'll try to notice, and or you can scream, and then if we hear it and notice, then we will try to talk about it. So yeah, don't wait, because if your question goes away, then it's gone. And we also love dry jokes. So, what is this talk?
Well, we had a number of discussions over a beer, and it came out that we witnessed a lot of problems in the systems that we build. And some stuff might be interesting for some of you. And together we worked with large-scale event-driven architectures. So we definitely want to share some of the observations that we have.
And obviously this collection is not exhaustive, and there are more ways in which you can make things bad. And we've seen more than we have been able to fit into this talk. And you might have witnessed some. You might have gory memories if we bring them back to you, sorry, up front.
What is this talk not about?
So this is not an A to Z, Alpha to Sigma, or any other Greek letter tutorial about how to do an event anything system. That would be a number of separate talks.
And the other thing, apart from graphics, it's not generated by artificial intelligence. So it's actually our chats and conversations that we turned into notes. So nothing here is generated by AI.
So what is an event?
Oh, that's a very, very interesting thing, because I guess depending who you ask and what are the circumstances, there you will have a lot of answers. I would say, what is an event? Come on, a couple of quick thoughts. Something that happened, yeah.
Yeah, you got the second point. Good. Anybody else? Anything? Will help. A discrete fact, so something has happened, the something is quite concrete, and is discrete because it's not as opposed to continuous. It's in past tense, so it happened, and it means usually it is attached to a specific point in time. We'll talk about time later, but that's the basic definition of an event that we're talking about. So that sounds easy.
Yeah.
How could you possibly?
Let's do events, right? Let's install Kafka, and what can go wrong? So I would say the first mistake usually is not making events. So if you have architecture that doesn't require events, maybe lucky you, maybe you actually didn't took everything into consideration, all of the requirements or specific needs for integration and so on and so forth. So what might be the symptom? So batch sticking state changes. You may have huge audit tables. So if you were at my previous talk, I also spoke about this situation where you actually build something to support some requirements, like for instance, auditable tables, and you in fact do something like events, but not necessarily. But you build it, for instance, on the top of a CRUD. Some other heuristic, I would say, would be we open the code, we see strange facts, things doing a lot of things at once, right? So that's usually another good heuristic when this situation happens. So what might be the solution? First of all, let's introduce the concept of event to our systems, right? So let's make sure that we have this discussion with the team. Let's make sure that we understand what are the events and how to use them properly. Let's make sure that we store them in the same place, right? So that's the
same database, not the same table.
Exactly. And let's start, I would say, slowly but surely. The other problem that we already discussed is creating audit tables instead of events. So that's something usually what happens. So you would create a concept of an auditable action, for instance, and try to store it for the sake of auditability.
But rather than storing what has happened as in the events, so something that makes a story, you store different versions of the entities. And that means that you have to figure it out, see what happens. You end up with a kind of some sort of an audit processor, which is trying to look for changes and make them into those entities that you should have stored in the first place.
And make sense of it. In other words, you will parse that data to try to make sense of that. But, Andrzej, we can go the other way around.
The other extreme is quite simple. You go all in on events. Everything is an event. System has 7 bazillion queues. Every single technology known to every single species on Earth. You have Kafka, Kubernetes, Apache, Pulsar. You have ActiveMQ and ZeroMQ and RabbitMQ in a single process, in a single system, and maybe Redis as well. If somebody goes like that, well, you can see that this is overdone. But all in on events. When does this happen? Events are great, but they are not great for absolutely every single thing, and they are definitely not a silver bullet, golden hammer, a magic tool for everything. So it is okay not to go fully into events. Sometimes you want to send some internal events internally and not externally. You don't have to apply the absolutely same pattern to anything that mentions the word event, and that means that you have to do everything. No, you can. It can be different. Some events are actually not important. Some will be very technical. Some will only be there so that the example with the method that says end, so that you trigger the other steps in that complex process, and that's all. And then they can disappear because you don't care about them anymore.
I think I can add to that quite often what happens when I join the teams is the team usually is one or the other, right? So no events, we don't like them, or we do event-driven architecture for the win, like big time, right? Everything is an event. There are different types of events. There are integrations events. There are domain-driven designed events. There are different tools. So learn why do you want to use them, right?
But that's another. We'll come back to this area as in. What tools and techniques you can use to actually figure out which events are the important ones? How do you differentiate?
Okay.
So we have an event. Event needs an ID. Obvious, easy. What do we pick as the ID? Well, if we are early on in our careers, we pick an int, and then we learn. Or somebody might be smarter because, well, an int is going to, we were going to run out of value, so we're going to pick a long. Or maybe we're working with some fancy people in the front-end department and they pick nano ID because it's fancy and cool, and they are all great, but we would actually advertise to use something that's predictable and that you can enforce a schema of, or maybe not enforce a schema of, but a structure so that you can see whether this makes sense as an identifier of an event. So, for example, UID. Anyway, one big mistake here is if you have events in your system that you originate and you mix the IDs, then trying to correlate and understand what is what would be hard. Don't do it. Be consistent.
So, what are the choices?
Ints, we discussed. Also, anything like an int or a long or something that's very sequential can be enumerated, which means if you expose events by ID through some sort of an API, you can easily let somebody figure out how much activity your system has, which might be completely irrelevant, but if you're in a I don't know, startup acquisition mode, or your company is going to be acquired, or your competitors are really trying to understand how much business you're having or dealing with, then they can infer that from how much the events numbers are growing. And that's not great. So obviously we will pick something random. So probably UID. That's cool. That also has a structure because you know what the alphabet of values available is. And then you can verify that easily. And then it's all good and merry and jolly until somebody wants to introduce something fancy like, I don't know, a nano ID, which has a wider alphabet, so it's shorter, but it's hard to understand whether that's just random gibberish or an ID. Don't mix. Nano ID, if you haven't met, that's a thing that exists. As in, there are some facts. Feel free to look it up later. Usually, from our experience, UIDs are quite unique enough to serve as a correlation ID. So if you use this as an identifier, you can also use it as a label to put on other things to understand how those interactions, correlations happen in the system. And so, dear audience, this is the UID. UID, this is the audience. Now you know each other, easy. Everybody knows everything. Some people might also call it GUID, if you're on the Windows side of things, but also, what is very important to mention, some databases can store UIDs as their own type, because those are bytes under the hood. Don't store, for the love of everything that's beautiful, fluffy, sacred, or whatever else you care about, them as strings. I think that's very sad. Don't do it. It will be terribly inefficient. Yeah. And so UIDs, some facts, they have variants and versions, which those details are very well read through from the slides. You can generate them in the command line very easily. And then there is one quirk about version 3, which is string related. It's going to do a hash of a string, and then you can see that those UIDs are the same. If you, for example, generate them with a timestamp built in, then you cannot see it too much because it's yellow and small, so I'll try to put something in a frame. UIDs can also be related to your network interface. As you can see in the slide, which network interface? Well, good luck guessing. If something changes, you replace the network card, you start generating different UIDs. Not great. So don't use this type, basically. But also, what you can do in UIDs is you can store a timestamp. Timestamp goes from year 1582 in some strange increments. Extraction codes or putting the timestamp in there is doable. So if you are using time-based UIDs, you can maybe use it to relate to a time, or maybe not if you don't. That generating UID from instance, as in that's a sample code, I might have tried to do it with ChatGPT, and I don't think I worked successfully, so I had to write it by hand. This is quite useful if you have time-based UIDs and you want to look up an event or some in the database related entities, because you can, for example, narrow down the timestamp scope, and that means use better indexes, help database do less work. And this is quite powerful, but
that means there's a few things, like ordering. And here comes the new versions of UID, if you don't know. So there will be version 6, 7, and 8. I think they're in draft.
Yes.
Yeah, and they will be very interesting. So actually, as you can see, version 7 will be orderable by timestamp, and version 8 can help us implement some custom logic. So you will be able to handle IDs even more efficient as a UIDs.
Great. Okay. So should I use them everywhere?
Yes, but
what's the but?
Go for it.
Composite keys. Any UID will look like any other UID, which means if you get two events, you will have a hard time figuring out what event is that. So you would like to know what event that was. I don't know. Order created, customer joined. In one area, this might be the same name that somebody else would like to use in a different area of the company, especially if you work in a big business or have a very complex domain, which has very many points of view on similarly named entities. So better than name and identifier to also have domain or bounded context name, name of the event and the identifier.
That's the part. Therefore, it will be much easier to understand in a large system what is your event about, right? And integrate with the larger organization. Good. I want to talk to you about one of my favorite mistakes. Design for delivery mechanism. What do you do for event? If I ask you for a system designer interview, I guess I can foresee what will be there. Kafka or a blockchain, if you're really into some chain-based stuff, or anything that you insert here. And the problem is you design your system for the message broker, right? So you can insert anything. Usually during the discussions that we meet the teams, there will be discussion, for instance, yeah, we want to use PubSub Kafka. You put it whatever you want here because it's not modern enough, it's too modern enough, it's we believe it never crashes, etc., etc. And you design your event-driven architecture for these systems. Okay, solution. Start with the use case. So why do you want to use the event? We started already mentioning there are different types of events. You can have different delivery mechanisms for different use cases, and you can separate those, right? By the way, this is a disclaimer. That's not the point to make this decision. I can tell you Postgres is one of the best technologies to start with. It's scary good. To actually convince you, I can tell you Revolut with its scale, 35 million customers at the moment, runs even message broker on Postgres. It doesn't have Kafka. And imagine how many transactions per second do we process. So Postgres does it really, really well. So come on, relational database as a message queue. Wow.
I know of an exchange that uses MySQL or something. So yeah, relational databases can work quickly.
And I would say whatever your team is used to, right? That's a right tool. So if you're on the certain cloud, choose whatever the technology is there.
And there is one caveat here as well. Maybe not a caveat, but an expansion. If you're starting with events, you don't need a broker in the first place. You can just put events in the database because what you care about is storing the story that happened to some things, some entities, some objects. And this is where the value is. Actually adding technology to deliver them remotely, maybe, or maybe not, because maybe the database would be enough, especially if there is not a lot of them.
Caveat number 2, immutability of the event. That's the first thing that we're being taught, right? Events are immutable. You cannot change them. Are you sure?
Never have I ever.
Exactly. So we never change events. Well, I was working with Hadoop, so that was usually hard, but in some rare cases, you really want to do that. So it will be helpful. So imagine you're a bank, coincidence, and there is a GDPR that comes out, and you really need to remove all of the personal information from all of the data that you store, but you don't want to get rid of the events. What can be helpful? Well, mutate your events. So build something that will go through all of the events that you stored, and of course change them. So funny enough, events are not necessarily that immutable.
Also, a lawsuit might come, or a judge, a court, a tribunal might order the company, the organization that you work with, to eradicate certain kind of information from its systems. And the court will not be interested that you have this on the blockchain. It will tell you that this information shall no longer exist, or you will be fined, and fined very well, as in lots of monies.
I'll come back to GDPR because that's a very interesting case. So if you're in our profession for longer than probably 6-7 years, you remember then we build our systems, then suddenly GDPR came out and we had to adjust. What's the good workaround, and I hope it's already like a standout in your events. Use identifiers and tokens. Do not use the personal information in the events because you will regret it. Because you need to speak also to your legal teams. So if you do software that handles personal and identifiable information, speak to your lawyers, check regulations, understand what are the requirements. And by the way, align with your company. What is the understanding of personal information? Because that's also one of the things that will be helpful.
And that also affects storage. How long can you store information for, and how long are you legally required to store information for? Certain domains, let's think medical, aviation, maybe finance, maybe something else as well, will be ordered to store information for X amount of years. That usually trumps rights to be forgotten. So the company has to maintain the data set for X years, and there is no way around it. So if somebody asks to be deleted, yeah, but not fully. Sadly, there is no simple get out of this difficult area scenario other than talk to your lawyers or business people if they are savvy enough and understand and agree on what it needs to be done and how do you do it, and write it down somewhere so that it's explicit, because this information not doing it properly can lead to funny situations like we're observing in the US or maybe have recently. Which brings us to another one.
Multiple delivery brokers, what about them? So
imagine there is a component and there is another component, and those components will communicate through web services. Sure, cool, but also open a WebSocket and also talk through a queue. You make funny faces, I did as well. But there are some systems which do that exactly. The problems that they have, or the symptoms, is that they have multiple channels between the same two applications. This is nonsensical, or we all seem to know that this is nonsensical, but those things still happen. What it means then, in consequence, is that the order of events in the entirety of the system is not really deterministic. You might miss events. You might try to retransmit some events from one layer through the other, and then, well, good luck. How do you notice that you are having a big problem with that? Well, there is a lot of compensating logic that tries to make sense of whatever arrives through whatever means. And the solution is, I'm not saying anything radical. Don't cause the problem, refactor it out and fix it. Lambda architectures, if you worked with data, big data areas, they always, anybody who dealt with that spent some time dealing with data drift or difference between the batch and the event-based. The only way out is to just use one source of truth and be consistent.
Another mistake, serialization.
So how do we serialize objects in Java? Well, Java, easy. You just save the object into the DB and we've won. Is there anybody in the room who doesn't know why evolving end classes which are serializable and then trying to restore them will fail? If not, if you don't know or if you don't feel entirely comfortable, talk to us after. We'll explain. TLDR for everybody else. Serialization in Java and evolving your code don't work together too well. Obvious answer. JSON to the rescue. We put maybe an annotation somewhere, and our job is done. Yeah, so mic drop, I think we can go. No, not really.
But a caveat to the serialization. So test serialization, test symmetry. So serialize, deserialize, of course, and test the serialization of older events. So of course, if you're lucky and you have your system in the production for years, your events will change and test them as well.
And you might find our recommendation to test serialization and deserialization a bit, aren't you overdoing it? But in most of the systems I do, I try to have tests around that area, and they have been worth it every single time. Not having it means you avoid, you might get into a nasty surprise. It's great that you use gRPC.
You will be surprised when that stuff happens.
I'll start deserializing using Jackson, and then we try to reverse or maybe upgrade a library version, or maybe somebody renames a variable name. Trivial refactoring, IntelliJ went with that perfectly happy, and then you cannot deserialize old content anymore. And this is the thing that you discover with a sea of 500s, or maybe a number of errors in monitoring if you have it. And what about all things? It doesn't take a long time to write a test, just write them.
Versioning of events. So, of course, we produce our first version, we're successful, then comes the product owner and the changes and so on and so forth. What happens? Well, that's worth a whole talk. And we can recommend the book by the famous Greg Young, Versioning in Event Source System. So there are different approaches. Very, very quickly. So the threefold strategies that you can actually use. So get used to them, treat them as a tool, understand what are the benefits and the problems.
Or if you get to meet Greg Young in person, that's a great conversation subject.
It's very hard to meet him in person lately, by the way.
So
lack of schema.
We stored events. What did we store? The answer is, I wish I had a schema. How do you know that you really wanted to have a schema? How do you infer it from the code that what you are missing is the schema?
There are a couple of symptoms. So let's say you consume these events and you come to this point where there are a lot of if-else when you read the events, right? So what really happened is really most likely we started to evolve the schema, and of course the problem is content is unpredictable and errors will accumulate over the time. And of course I think we've been there, that schema-less or schema-flexible for the win. So this is maybe not necessarily. And the solution is have a schema. So make sure that you actually document events and document them like endpoints. We'll come back to that in a moment.
So how do I enforce a schema? Is my Java code enough?
Java code can be good, but is it convenient for everyone?
If you work in an organization that everybody works with Java and everybody that touches those events also works with Java and Java only and everybody is super comfortable, sure, that's great. The moment you invite other technologies into the conversation, and I don't know of too many companies, for example, without Python or Go, maybe a bit of Rust somewhere, whatever, and then there will be data people who will try to do data things.
Then there are a couple of better solutions. So if you worked with Kafka in the production, you probably heard about our big data, Protobuf, JSON schema, and some others. So definitely use them. There is another caveat that comes with this schema, is naming. We call this Schrödinger's event. So in other words, what the hell is this event? So if you were working in big data technologies and, for instance, and you had a lot of events, you come across order placed. Like seriously, what is this event about? Payments, logistic returns. Who should I, if I write the data pipeline, who should I talk to if I work with them? Or, for instance, storage, I collect storage requirements. What are they, right? So make sure that your naming conventions are easy and understandable by everyone. Returns order placed is definitely better than order placed, right?
But ideally order placed with a comma, domain element, and then the ID, the complex identifier that we told you about in the beginning.
That would be ideal.
We store that, we have those JSONs with some schema. Is JSON okay? Is JSON actually too verbose? Should I panic?
Well, you may, but...
So, what can we do with those JSONs? Yes, they are verbose, but they are the standard. So we just live to accept it. Rather than telling you what Cloud Events was, I'm not even going to say too much because it's kind of bad. Rather than that, async API, this is open API for async things, or extended with support for async things, like the Swagger, or open API that you know and love. And it can do both, and it can also generate the documentation. On the left is YAML. If you hate YAML, I'm sorry. Let's convert that to JSON. Now you should be happier. The content really doesn't matter. You know the association. It's possible to do this for events. And if you don't, or if you've never looked at it, I would encourage you to, because if events are important for you, that will come in handy. That will come in handy, especially if you want to integrate across multiple teams. In a 5-people team, it's enough to talk.
And events are usually used for integration between teams, right? So that's very useful.
You can even get samples in here. Of course, the fact that it's at the very bottom means, well, you can't really see it, but it's there.
So I guess on your TV, that's even easier.
We've talked about schema. We know a way to publish it. What should we actually store in the event? What should be the contents? What options do we have?
And there are a couple of I would say schools, right, or other approaches. So you can store the fact that something happened. You can store the delta between the state of the system before some operation and after the operation. You may do a composite event. We'll come back to those, to be honest. So there are a couple of approaches.
Sadly, the answer to which one should you use is as many consulting or software answers. It depends. It depends on many, many things. In short, if you're event sourcing, which means you derive the state of entities from the events alone, and you're doing that within your system and that's all, deltas are great, because deltas are how you're going to operate with anyway.
They're easy to aggregate as well, right? Yeah.
On the other hand, the moment you want to ship your state, your events outside to somebody, like the example that we've had in here, be nice to users, give them facts, and maybe if the previous status is useful to them, sure. Yes, it bloats it by a line. Those 60 characters, I don't think we care about that much, but it's actually useful. And the more data you put into an event, the less calls will need to follow somebody receiving that event in order to figure out and fetch this information anyway. So that's one of the trade-offs. Another aspect, ship what's useful. Imagine the user of your system. If you want them to act on the event alone, give them everything that's necessary to act on it.
So there is far more about the topic. So happy to have a chat and be challenged on that one. Guarantees. So that's the.
Let's wait. Let's let people read it.
Yeah, that's the best, I think, summary of the problems that we have with event-driven architectures, right? So that's usually the problem that you will face if you really design your system to integrate on events. So remember about guarantees and order of events, in other words, or I should literally quote it. With guarantees, can you tolerate missing events? So what do you do? For instance, at least once, at most once. So first one is check inbox and outbox patterns, right? So if you really need to make sure that there is there are guarantees that are important, make sure that you understand inbox and outbox patterns. In other words, receiving events and handling duplication, or checking if we should send it, right? Hence inbox and outbox.
Is anybody unaware of what outbox or inbox pattern is? Just feel free to raise your hand. It's 2 sentences to repeat it if you do. Okay, so in that case, outbox pattern is when you do a business transaction and that transaction emits events. In a database transaction, you store the change of entities and the events in a single database so that you get atomicity of the storage. And then there is a process that will fetch those events and deliver them to a broker, however you want to distribute your events. Easy? Makes sense. Great. Inbox pattern is the same, but the other way. And now you know. As I said, 2 sentences.
And that was Andrzej Google, by the way, not mine. But this is what you get from the outbox pattern. So I think it was the Google trolling Andrzej. What can possibly go wrong if you rely on the outbox pattern too much? Because there is a problem. Then the problem happens is you need to be prepared that, by the way, when you design a system, things break. So you need to be prepared that your event table may go down, be unreachable, and you need to handle such case. And of course, there are, if you send an email twice, that's fine. But if you charge the account twice, that's the big problem. So of course, there are gradations of different problems that you solve. Another thing that we saw is massive events. So the symptom is that you're being contacted by, probably in the worst case, CFO in your company when they receive the bill for your cloud. But first, hopefully, your sysops team will tell you, for God's sake, what is going on here? And the problem is that, for instance, you're using too much disk space, network burns hot, etc. And please remind me, but I think in Kafka the size of the event is 16 megabytes, as far as I remember. So imagine 16 megabytes of data, and imagine that there are systems which can go 100,000 events very, very easily per second, right? So imagine how problematic that is. So very often we see that too much information is serialized, stored, transmitted, deserialized. So what is the solution? Make sure that you understand what are you using the systems for. Therefore, you can maybe make them leaner and not transfer all of the data.
If you don't know what you require. Set a limit, set something reasonable, I don't know, maybe 128K, or maybe I've heard 640 kilos should be enough for everybody, so maybe that's a good value. Set a value, set a limit, something that feels reasonable, comfortable, that will allow you to go forward, and you will not cross it. And then when you cross it, you'll get some exceptions, but you will have a signal, because you want that signal. And then maybe some classes of events, some events in some domain can exceed it, set the value, or maybe what will happen is somebody actually tried to push an entire aggregate and all related entities through that event. And that happens. The way to pick it up is, have those alerts. This is especially useful to do if you ship those events externally, because you might, by a mistake of putting a field in a field and using some magic serialization framework, share with the entire world half of your database. Or maybe not half of your database, but basically the customer with all the details. It used to be an extremely popular mistake with a certain document-oriented data store, but I will not mention its name. It's 5 letters.
Another problem, one of my favorites, the mighty time. We pretend it doesn't exist, don't we, in our systems? So if you see the event, one of the fields that you very likely put in the event is timestamp. And let me ask the question, what the hell is your timestamp? I mean it, like seriously. You created this event on the mobile phone probably, you received it, you started to do something on the fly with it, you stored it. The when is becoming a very, very hard question. And now imagine you build a very massive system based on the events and you need to debug it. And you have problems with understanding exactly when stuff happened, right? So this will be exactly the questions: when did we receive it? When it was processed by Flink or whatever, etc., etc. So it's a very important question. Couple of solutions.
Solution number 0, because we're those kinds of developers, use Lamport timestamps. That's a very fancy way of saying use processing counters. The first time you deal with an event, it has a 1. The next time you do something with it, it gets a 2, and so on. So if you keep shipping it further and further, you increase it. If you know network packets, it's like a reverse of TTL. This will be a very useful signal if you, for example, cross 200, and that's a value completely out of thin air, or maybe 256 to be nice and round, then something has probably gone wrong. Maybe you will have a need for something like the letter queue, or maybe you just need to reject the event. But that's not all. Counters, cool, but with time.
But make time explicit. So don't use timestamp, please. Created at, received at, processed at, stored at, whatever you want. Make it explicit. It will be so easy to debug the system and build on top of that. Also, it will make it very, very helpful if you need to make business decisions on the fly based on the events. So let's say you're a telecom or you're a bank and you're processing events in the real time. And if you have all of that information, there are certain cases that you will be able to solve right on the fly. Distinguish local and zone time. So make sure that you're agreeing the company which one are you using. And if you're hosting your own machines, make sure that you use NTP for syncing clocks.
And if you're using Minikube to test or run your applications, there is a few incantations that you have to invoke onto the Minikube cluster so that there is NTP enabled within it. If you don't, then you might get funny situations in which you send something into the Minikube and the time there is either from the past or from the future next to you. It's within your desktop, within your workstation, but time there, because it's a VM inside, it might already have drifted. It's very fun to debug that.
Okay, there is another great thing with events. We think that will solve all of our problems, don't we? We scale the companies up and we deny the distributed systems.
So the moment you convert your system to talk to its components with events, or differently, if I send a request to you and it works, I know. If it fails, I know. If I send an asynchronous entity in some direction, how will I know that it was processed? And then, if there is a complex operation at play, how do I know that it's still processing? How do I know that it died? How can I say where are we?
So why is this hard? So events are published and consumed by different services, right? That's the whole idea of event-driven architecture. And they live in their own separate realms. It's really, really hard when you start doing event-driven architecture. You have multiple services to do distributed transactions, which are atomic and consistent. So how do we make sure that such systems are consistent, right? That's the big problem. And the other thing that happens very, very quickly is dependencies and coupling will go off rails, like completely, because you will see that actually the whole transaction can consist of invoking, for instance, by transaction I mean some business process is, for instance, dozens of services down the road. Right, so that's quite often what happens.
And because events hide this complexity, that becomes very, very easy and quite explosive. You can have a nice diagram.
Yeah, exactly. Understand what now means in your systems. So make sure that you understand exactly what it means. Get comfortably with eventual consistency. These two things are quite important. So we often talk to our product owners, by the way, a side note, and they say, if this happens, then that happens straight away. Come on, we're engineers, real time, straight away. We know what to do, right? Ask the business product owner, what do you mean by straight away or now? Very often they will say, oh, the same business day. That's a completely different problem. And the distributed transaction may become very, very easy to solve. Because instead of doing everything immediately, you may actually do some other stuff, and you don't need to have such a complex system.
A simple way to think about it is, whenever you see eventual consistency, rotate the term. Eventual consistency, immediate inconsistency. How long can it be inconsistent for? When will it be a problem? If you approach it from that way, that will help to drive and guide you during some of those conversations. Some other aspects, use idempotency keys so that you don't keep reprocessing the same thing over and over. If I want to initiate a transfer of funds and I click on my mobile button because of the networks, my request got multiplied. Obviously, I don't want to send all of my money somewhere, even if that's a very charitable cause. So put them in and verify that you're not reprocessing over and over. And also, if your event processing logic grows in complexity, give some thought to a process manager. Build the infrastructure that will help you, tell you what's happening in the system. How is this transaction going? How many distributed transactions or distributed business processes do we have in flight? And where are they? So that you can have an insight into the system, not only from this message goes through that broker there, but what is the meaning of all this?
But I would say, you will see a lot of courses saying, we will teach you how to do distributed transaction. I would say, you were warned. This is really tough. And I mean it. Building a good transactional system on the event-driven architecture is bloody hard. So consider yourself warned. With that, let's go. Tracing events.
We received an event. 2 questions. Who sent it to us? Where did it go? Where should it go? If you don't follow that, if you try to make a diagram, you might end up with this beautiful picture that somebody said that this is a microservice architecture. My interpretation is I beg to differ. That's all I'm going to say. But for events, it's harder to get those flows because if something is very asynchronous, how do you know? You actually have to trace every single event and see what happens in the system. Even if you trace, what might happen is you might end up having a circular flow between a couple of components because it's all asynchronous, and asynchronicity hides things and hides details and can bite you. You can have a cycle, you can have a reinforcing loop, and that's even funnier. But that's why we mentioned processing counters. If you keep processing the same event, if somebody reached 1 million, not only do they win, but they should stop immediately. How do you prevent this? What are the techniques that you should put in place so that you can figure out something is off?
Tracing IDs. So in other words, put an event when it starts, when some transaction happens, put a transaction ID, the trace ID or correlation ID, and then throughout the system, use the same correlation ID. It will build a whole tree of everything that happened in the system through all of the events, through all of the operations that you will invoke, etc., etc. So it will be easy then in the logging system to understand. Okay, if I click that, there is a whole thing that happens, right?
And distributed tracing is something that has had a couple of talks already at JDD, maybe from the past year. So go through the YouTube channel. Definitely there will be wisdom. But then we promised you an answer, or to point you towards getting an answer to how do you figure out which events matter. Wojtek, that's your show.
Okay, so not events are equal. And if you see the sticky, you know probably where I'm going, right? So first of all, good candidate like that. It's hard to roll back moments. So if you have a situation like that, think about that's a good candidate already for the event. Second is stuff that people care about. So whenever you see the thing that people care about, it is actually very useful to think event. Pick the right event. That's not the talk about JDD, but hey, here we are again. Event storming for the win. So use this, learn this technique, use this technique. It will actually help you to identify which events are truly important, also which can be internal to your domain, which should be external and used for maybe event integration. Second, not events are equal. Again, there is a whole talk from this guy, and he proposes three types: notification, event carrier state transfer, event sourcing. He also talks about CQRS in this talk, but that's another thing. So notification is, hey, I did something like that, do whatever you want with this message, right? Then event carried state transfer, hey, I did that, and by the way, there is a whole data that you need to know about that. And event sourcing, of course, it's the pattern on itself. Good. Poor quality systems. It's a big problem with event-driven architecture.
It's always the third party's fault. You will have to integrate with terrible quality third parties, and they will give you events which are untrustworthy, very bad quality, and that's a fact of life. We all know that. We all don't love it, but we have no choice.
You will end up with systems that are hard to maintain, hard to debug, painful. So as I said in my previous presentation, there is a temptation on put that resignation letter on the desk at some point. Before you reach that point, there is a solution. Start from the business context. So we discussed previously, talk about the ubiquitous language, but you can call it glossary, whatever. Make sure that you understand exactly what you're doing, in other words. What is this thing? If I say payment transaction processed, everyone should understand exactly in the same way. It really helps, especially if you integrate through events in the larger organization.
Which means if you join a company that has a dated code base and you don't understand it, the team doesn't understand it, what you can start is just start making notes, make Java docs, even all those events. Maybe rename some classes, maybe introduce events which will be garbage collected, which will be there for you as a documentation so that you can learn the system and see and try to reason about it, even if you don't store them immediately. There are obviously different problems in different systems, but naming things well helps us, the protein interfaces.
There is this thing that is quite also useful, is pivotal events. So hands up if you heard the name of. Okay, pivotal events, it's like an important event. So these are your significant domain events, meaning that these are the events that you and a group of people will care about really, really badly. And this is very, very useful, especially for separating your internal domain with the external world. Here is the example. Let's say I'm working in a suspicious transactions monitoring, right? So whenever your bank calls you, I'm really sorry, do you at this moment buy a MacBook Pro in Shanghai? And you say, oh, for God's sake, no, this is the case, right? So these are the guys that were working. If they put all of these events on in our architecture, that's probably not the case that we want, but suspicious transaction blocked is the event that everyone cares about. Other thing, consider event sourcing. So we can audit the system, we can reconstruct past states, and we can flexibly apply changes in the past. Especially if you were working with data analytics and machine learning, they're very useful also for testing hypotheses. So you collected a lot of events, and you can also run different hypotheses for the systems on the historical data and do some kind of what-if analysis on the real business cases, actually. You don't need to build the test data.
So you take the events, you replay them into whatever bucket processor you want, and you see what you get.
And you see the result. Consider CQRS. So separate the command and queries side, right? So
the writes from the reads.
The writes or the reads. Basically speaking, break it down with complex systems. Make sure that queries are there, very simple. Commands are handling the logic of the change state. The problem that we saw, extra mistake.
There is a bonus material. The bonus material, obviously, with CQRS and event sourcing, is trying to put it everywhere.
Especially if the CTO goes for a talk and sees how beautiful CQRS and event sourcing is, right?
Some systems don't need CQRS and event sourcing. Some people try to overdo it. Some systems are absolutely okay as I call them CRUD, you call them API to the database. There is even, I think, a Postgres, maybe a plugin, maybe something that works with Postgres that basically exposes all the tables using REST. I'm not going to say that your system needs that in its entirety, but maybe some components are exactly what needs that because that's what you have. Another aspect is you might have two different types of read models. If let's use a bank account and transactions. When I, the user, look at it, I want to see the current state. I want to see the end result every single time, or in most cases.
In most cases.
The systems will care about how it happened. Those are two different concerns. Don't try to conflate them. If they are very different, if it's extremely awkward to make it into a one read model, make it into two. That's okay. And extra mistake, CQRS event sourcing when you need audit, but you need basic audits. If you need basic audits, then actually doing those audit tables is okay, and you know that it's going to be okay for the next 5 years, it's okay. We're not saying that there is a silver bullet kind of technology. But
I would only add one thing. We often over-engineer. This is like our sin. Like the first thing we usually do is over-engineer. I would say get comfortable. A lot of systems are CRUDs, nothing else, like API to the database. Get comfortable. Some systems will benefit from the fact that you separate this logic, and so on and so forth.
And so for some takeaways.
Get your cameras ready. These are the books that we recommend.
Or send us an email and we'll send you the slides and you'll get everything, plus the links to the talks. Which one of those books should you start with?
That depends what you're looking for, right? But I would say definitely don't start with the blue book. It's quite hard. I had a talk a few years ago about introducing domain-driven design. So I would say learning domain-driven design. And funnily enough, I will repeat myself, but this is Java Conference, but this is the best book, introduction book on the market when it comes to get comfortably to architecture concepts that we were discussing. So you may laugh of Python, but they wrote a really good book on the architecture. With that, thank you very much. That's it.